Phi Steel thread demo. Phi, if you remember, is the program that is building the graph of graphs for Atlassian's first and third parties to build with the core capabilities being the graphical gateway, the graph store, and the manifold data model. As a part of the Phi Steel thread, what we are doing is putting ourselves in the second and third party shoes and imagining to ourselves what it would take to actually build an application on Atlassian platform using the Forge and Phi capabilities. So if I were a second party developer today, I would want to define new entity types into the Atlassian data model for the application that I'm building. And this is what you would actually see in V1, where I'm able to read and write my data through my own API. And going forward in V2, which we will demonstrate in January, we'll be able to associate this new data type with existing Atlassian data types, such as a Jira issue or a Confluence page. And obviously, we have a long roadmap to build more and more interesting things with the Atlassian platform capabilities available. As a reminder, what you would actually see today in V1, while it is just defining a new entity called Magic Task, it is actually using Manifold as a completely self-serve capability to be extended. And then as a second and third party developer, what I'm able to do is not just extend the data model, but also create my own API, stitch it together in the Atlassian graphical gateway while storing the data in the graph store. Remember, this is something that is not easily possible today, requires a ton of coordination with not just product managers within Atlassian, but also first, second, and third party developers, the engineering team within various different products who we want to integrate with. What we have done here is a completely self-serve model. So please enjoy the demo.
I would like to stop for a second and explain why a seemingly simple spike delivers results in steps or versions as Anand just.
It would be an oversimplification to think of Phi as one-dimensional progress. Like, here's a ladder, and each step unlock an incremental customer and business value. Yes, here's a ladder, but it's also a multi-dimensional space composed of different Atlassian capabilities. All those things being developed at the same time with dissimilar speed and ever-changing priorities by different teams. And all of those initiatives have individual business and value by themselves. But when taken together, they multiply each other. And Phi program is here to bind those isolated values all together for a greater whole. So every effort to bind a few capabilities together has to be limited in scope to be practical. So those rings that you see right now are the effort or quantified efforts of the steel thread steps. Our work is designed as a spike project where every step is probing the water on the next ring. To fully productize the solution of a steel thread step, we need other programs to be fully developed. This is our external dependencies. In the same time, we can paper over those holes, we can know deficiencies and record missing capabilities and still show what the end result would look like once everything is done. Today, ignore the actual customer value of those demo apps that you will see. They are for demonstration purposes only. But from the technical point of view, we engage and use all the building blocks, all the APIs that a typical first, second, third-party developer would have used anyway. So when step one of version one of the steel thread, a developer creates a new Atlassian entity type that didn't exist before, gets the create, read, update, delete CRUD API to automatically show up on the single Atlassian API endpoint, and also get the enterprise data store provision to store it all. So you can think of it as first-party feature development. You can think of it as a third-party data ingestion. You can think of it as a new workflow on Atlassian ecosystem that hasn't been there before. So the first step requires a number of services and capabilities to work in unison, even the first step. Forge with its own cluster of services inside, a few services that we collectively call provisioning, a managed DynamoDB, it's basically TDP with all compliances taken care of, a place to store and discover relationship between data entities. A new API needs to magically show up on a single Atlassian endpoint, schema here, schema there, authentication, authorization, quite a bit of work. And in a moment, Philippe and Faizan will do a live demonstration on how manifold graphical gateway, request routing, entity storage, all get provisioned, all get configured, and they work together. They will show how request and data flow in both command line and UI cases. But first, let me show how this version one of the steel thread is relevant in the context of other Atlassian initiatives. Let's take DevOps, for instance. Here's what DevOps and Compass teams want to see out of all of it. They want programmatic and declarative data ingestion from third parties. API and storages for third-party data should automatically be provisioned. They want self-service manifold integration for both their own entities that they're creating and the newly ingested one. They want request routing and data lifecycle management done by someone else. They want first-party entities, Jira, Confluence stuff, available in the graph store. They want data lifecycle for those Atlassian entities being managed by someone else. They want declarative permissions and access policies enforcement. They want data lifecycle for third-party newly ingested entities managed by someone else. They want organizational level workspaces in the graph store for data sharing. Basically, here's a list. And some of those capabilities we're trying as part of the V1 of the Steel thread. Others yet will come in the next versions. Let's talk about the Dandelion initiative, for instance. It's the same story. The first phase of the Dandelion is about Trello and Confluence better together. Simple boards in Confluence, simple pages in Trello. Know that these are not necessarily the Confluence pages. It could be any pages from any provider, even third-party competitors like Notion. Here's what Confluence and Trello wants to see. They want programmatic schema registration in Manifold, self-serve. They want programmatic API provisions in GraphQL Gateway. They want request routing to proper places. They want generic enterprise data store. That's mainly for Trello. That's CDP. They want declarative permissions and access policies enforcement. First, second, third party as data providers. First, second, third parties as workflow, user experience, capabilities providers. Organizational workspaces for data sharing, and first, second, third party authorization providers. Again, here's quite a list. And again, just like in case of DevOps, some of those capabilities we've been spiking as part of V1 of the Steel thread. Atlassian Economy, same story. Economy is our ultimate goal in general. And for the multiple economy orgs, there is something relevant in the Steel thread spike, except maybe for self-serve and high-touch commerce. For the demand side of the house, the most value come from the user-centric graph, which is a federation of everything we know about the particular user or segment of users. This includes integration with all the third-party systems that marketing use today, from Salesforce to the Mailgun. So in terms of Steel thread relevancy, we have external data ingestion and association, self-serve manifold, GraphQL API manipulation, and provisioning and request routing. Supply and ecosystem go hand in hand. Everything that is good for the supply stream of the economy is automatically good for the ecosystem. Apart from the obvious generic Phi goals, the supply would benefit from first-party core Atlassian entities available in connected graph, coherent API and schema, extensibility inward and outward, self-serve platform capabilities available in Forge, more workload that goes through Atlassian, more apps, more basically customers, more cross-sell. So all of those are rather high-level requirements, but we can already map a few of them to Steel thread V1 deliverables. As we go further, next Steel thread steps will bind and glue together increasingly more complex, more advanced capabilities. Okay, now time for the real demo.
Hey everybody, today I will demo the Phi Steel thread V1 end-to-end. In this demo, I'm hoping to show that these steps in this Phi Steel thread end-to-end demo script and basically verify that each of these can be achieved. So in summary, I want to be installing an app through the Forge CLI and defining the task model, and then show that the Phi provisioner service will then read the manifest data and generate and publish to Shipyard the GraphQL schema and have the AGG provision an extended central schema with the defined task model. And then I can show that the PGS proxy has fetched the schema from Shipyard and created storage for this task. And then after that, hopefully be able to write and read tasks through the AGG. So let's get started. So I'll just open my terminal here and I can get right into the Forge CLI. So I'll just go Forge create and app name. So we'll just call it task demo. Choose a blank template. Cool. So we've created the task demo directory. navigate to that. Yep, here we are. And then I can open this manifest.yaml file. So currently it's just a blank manifest file. I'll just copy this predefined. Sorry. Yep. So I'll just replace these modules. So here we have a task model. So we've got a task entity. It's got a description, URL, and then some field. So I should be able to save that and then deploy. And then install. So I'll just install into my Jira site. Yeah. Cool. So now the Phi provisioner service will pick up this installation event through Steam Hub and then basically kick off the processes to generate the manifold files and the GraphQL schema files, and then extend the AGG central schema and then upload that to Shipyard, and then the AGG will pick that up and then generate a whole service based on this extended schema. So I'll just head to the Shipyard UI and see how long. Okay, so it's not provisioned yet. Usually takes a minute. Cool. So we have it here. You can see modified 10:47 p.m. That's the current time. And it's created this artifact. So actually I can just copy this. This is the installation ID, and then head over to Insomnia. And this is an older one, but I'll just paste. So this is the AGG staging endpoint, and I'll just paste this as a URL path. That's the installation ID that we just provisioned. And then if I refresh schema, yeah. So we can see, so I was just testing before some random model chairs, but actually there's nothing called chairs. Over here we have tasks. So just go through the documents real quickly. Yep, tasks app, and then we've got tasks. So I'll just replace that with tasks, and then yeah, this is all working. So actually step 2 was verify that the PGS schema has been created. So I'll just head over to the PGS get endpoint and then paste sorry, it's in the query. So we actually need to paste the ATI, which is the Atlassian type, and that's just ATI cloud and the installation ID, and then the entity name. So if I send that, yep, we should get, this is the response from the PGS schema endpoint, and it basically shows that yes, we have created this model. It's got the URL, ID, and then there's some random field. Now we'll head back to the AGG endpoint, So right now, if I run this, we'll get null because we haven't defined any tasks yet. So I'll comment this query out and then demonstrate the mutation. So we can already see it's complaining because this was another entity that I was testing out. So it's already created a field called create task. And basically, yeah, we can just define these fields. So I'll just put in random number. And then a task for this demo, task ID, random number. And yep, we should be able to just send this, and yep, we get success. So I'll just keep scrambling the IDs. I'll create a dozen tasks maybe, and I'll create them across different cloud IDs. So just have another cloud ID here. Yep, cool. Copy that. Otherwise, I won't remember what I actually created. Cool. Okay. So now that we've created probably 5-6 tasks, I should be able to query them. So I'll just paste the cloud ID that I copied. This query field automatically generated. This will just return all tasks within a cloud ID. So if I send that, yep, we get these two. Actually, we just generated the one in that. If I copy this one, we've generated quite a few. Yep, we can see there's 1, 2. And then yeah, that's pretty much it. The next steps in this script was we'll write the task from Forge. So actually, if I head back to so we could actually put code here to call the AGG and generate tasks. I haven't done that yet, but that's something we could do soon, and then hopefully show a more front end kind of demo. So yeah, that's pretty much it. That's basically what we had for V1. And yeah, let us know in the Slack channel if there's any questions, and yeah, what if that matches the expectations that everyone in the team has.
The work we've done as part of the Phi Steel thread work. So first of all, I'm going to go ahead and create a new Forge app called Magic Tasks. And this will be a Jira issue panel. And yeah, while this is being created, I'm just going to get this new module here that we created called Phi Domain, which allows app developers to declare entities that their apps are going to use. So in this case, we have an entity called task with some simple fields like description, task URL, and icon URL. Just going to copy that, and let's go ahead and go inside the Magic Tasks source code, and yeah, if you go in the manifest and we paste like this entity definition, and also we want to copy and paste the component, the UI component code itself. So yeah, so this UI component will just use some new GraphQL queries that are now available to list and create tasks. So okay, I guess that's it. And now let's just install a local version of the Forge API package that we have, and let's just run yarn to install all the dependencies. And yeah, so the this is the code for our component that will be displayed in the as an issue panel. And yeah, it uses like these new fields that are going to be generated based on the entity definition here. So we have a query that will be used to create tasks, and a query that will be used to fetch tasks. And yeah, like the fields here are generated based on the fields that were declared as part of the entity definition here. Cool. So no modules is finished, and I think now it's time for deploying the app. Yeah. And yeah, once the app is deployed, we will install it into a Jira site, and it's during the installation step that most of the work actually happens, because we have a service that will be called upon the installation of the app, and then the service will read the contents of the entity declaration and generate the AGG schema based on that. Okay, cool. So the app was deployed, and now we need to install it. Let's install it to this site. The Jira site. Yep. And yeah, so it's installed. Now we need to run the dev tunnel, because there is some code in the runtime of the lambdas that execute the Forge code that were changed as part of the spike. And yeah, so we are running some stuff locally for now. Yeah, so this defines the function, and now we call the tunnel command. That's just because we didn't want to merge new code into the Forge repo, just to make things easier. So this warning here is expected because we have a new module that is not recognized yet. Cool. So now we are listening to that port, and our app is installed. Let's just double check that the new schema was actually published to Shipyard and picked up by AGG. So we looked at the AGG logs, and we see that yes, we have yeah, actually it's not yet completed. Yes, okay, now it's complete. So yeah, so a new schema was processed for our our Forge app. So we have our URL here, a unique URL for that app and that installation context. So if we go to the browser here, and we navigate to a GraphQL inspector using this unique URL, we'll see here that the introspection query is running, and when it's finished running, we will be able to see the new types that were generated based on the entity definition. So we can see here with the autocomplete feature that we have the magic task namespace, and it has the tasks field. Cool. And the tasks field has those the fields that we declared in the entity definition. Great. So I think now everything is working, and this is our site where the app was installed. Let's try to refresh the page. Yeah, so this is the new issue panel. Let's click on that. Great, so this is the panel content, and for now there are no tasks. Let's try to create a new task. Yeah, so the task is created, and yeah, that's it. We are able to use AGG to make calls to AGG to create a task and to fetch tasks, and all those operations use PGS as the data storage layer. Cool, so that's it.